Hello everyone, you're welcome to today's lecture. Today we'll be covering part 3 of soil chemical properties, and we will specifically look at soil pH as one of the key soil chemical properties. We can define soil pH in a number of ways. One, we can define soil pH as the measure of the relative acidity and alkalinity or basicity of the soil. We can also define soil pH as the negative logarithm of the activity of hydronium ions in the soil solution. We can also define soil pH as the measure of relationships, or the measure of the relationship of hydrogen ions to hydroxyl ions. Okay, so as a soil pH or a pH scale ranges from 0 to 14, with pH 7 being neutral, like we all know. So all soils with pH below 7 are called acidic soils, or soils with low pH, and soils with pH above 7 are called alkaline soils, or soils with high pH. Soil pH is therefore an important variable that affects all soil properties, which include the chemical, the physical, and the biological properties of soil. For example, for biological properties, the presence of given soil microorganisms within the soil will always be affected by the pH, mainly because certain species might not be able to survive in either high pH or in low pH. So what causes soil alkalinity? One, weathering of rocks, especially rocks with silicate, aluminosilicate, and carbonate minerals. Two, addition of silicate, aluminosilicate, and carbonate minerals to the soil by deposition. This deposition is mainly as a result of having eroded materials from a given area and deposition in that particular area. Okay, so if we have erosion from an area with a high composition of these particular minerals, it will lead to increase in alkalinity in the place where the deposition has taken place. We can also increase alkalinity by mixing soils with less weathered materials, such as addition of limestone in acidic soils. We can also have increase in alkalinity by addition of water, which contains dissolved bicarbonates during the process of irrigation or watering of plants. We can also have accumulation of alkalinity of a given soil, or in a given soil, in areas that are arid in nature or in arid conditions. Okay, so if we have areas that are experiencing droughts and they do not have water that is flowing through the soils, we may not have leaching or soluble salts. So there will be accumulation of these salts, and this will lead to accumulation of alkalinity. The alkalinity of a given soil can also be accumulated because there is lack of balance in the added cations. Okay, so for example, if we have addition of a large amount of sodium in an alkaline soil, there will be a tendency of inducing dissolution of calcium carbonate, which will end up increasing the soil pH. And let's also look at what causes soil acidity. Number one is application of acid-forming fertilizers, for example, urea and ammonium fertilizers. Okay, we can also have acidity increased when we have root respiration and decomposition of organic matter. These two have been combined mainly because as they occur, there will always be release of carbon dioxide, which when mixed with water in the soil will form a weak carbonic acid, which will increase the acidity of the soil. The other cause of soil acidity is hydrolysis of aluminium, and we see that hydrolysis is the chemical breakdown of a compound due to reaction with water. So when hydrolysis occurs, there will be increase in the amount of hydrogen ions in the soil, hence increasing soil acidity. The other cause of soil acidity is rainfall, and we see that acid soils are mostly common in areas with high amounts of rainfall. So when rainwater mixes with carbon dioxide in the atmosphere, there is always formation of carbonic acid, which might increase the acidity of the soil. Plant growth can also increase soil acidity, especially when plants take up much more cations from the soil solution. Okay. We can also experience increase in soil acidity when plants exude organic acids into the soil to acidify the surface or the zone around their roots. Okay. This mainly occurs to help solubilize metal nutrients that are insoluble at neutral pH, for example, iron. So in such a process, we will always have an increase in soil acidity. So the other cause of soil acidity is oxidative weathering, and we see that oxidation of some primary minerals, especially sulfides, can generate acidity in the soil. And we also see that human activities actually increase the rate of these processes. And now let's look at the effects of soil acidity on crop growth. The first effect is aluminium toxicity. And we see that when the soil pH drops, aluminium becomes soluble, hence retarding root growth, and this results into restriction of access to water and nutrients, which are very important for crop growth and development. And then the other effect is microbial activity. We see that in low pH, we normally see that there might be an effect on microbial activity, especially through decreasing the rate at which the root nodules are formed in leguminous plants. We also see that the rhizobia bacteria are greatly reduced in acidic soils. The other effect of soil acidity on crop growth is hydrogen toxicity, and we see that proton stress can limit plant growth. So the proton pump of the plasmalemma of the root cells works to maintain a near neutral pH of their cytoplasm, but when there is high proton activity in the external growth media or in the soil, the capacity of the cell to maintain the cytoplasmic pH is affected, hence growth shuts down. The other effect is manganese toxicity, and similar to aluminium, manganese increasingly becomes soluble as the pH drops. So at this level, or at this pH of about 5.6, we see manganese toxicity occur, and we normally see the symptoms. And these symptoms are normally characterized by capping of leaves, deformation of most of the leaves on the plant. So according to this picture, we see that in acidic, strongly acidic soils, all the major plant nutrients are deficient, but in neutral pH, majority of the nutrients, both the major and the trace elements, are available. But in alkaline soils, we see that all the major plant nutrients and most trace elements are not available for plant uptake. So what is the importance of soil pH in crop production? Number one, soil pH is useful in determining the availability of plant nutrients. So when you know the pH of that particular soil, you're able to know which plant nutrients are available. The other importance is that pH influences the availability in toxic amount minerals. Okay, so we see that at low pH, we know that iron and manganese are present in toxic amounts in the soil. And then pH can also influence the population and activities of beneficial microorganisms like rhizobia. So what factors affect soil pH? There are quite a number of factors. For example, climate, and when we are talking about climate, we are talking about rainfall and drought. So in both situations, we have different effects on the soil pH. And then the mineral composition of the parent material from which the soil was weathered can also affect the soil pH. And then the weathering reactions undergone by the parent rock can also affect the pH of a given soil. So in order for us to reduce acidification, we can carry out liming by using calcium carbonate. We can also apply nitrogen and sulfur based fertilizers according to the need of the plant or the crop. So you don't just apply for the sake of applying, but you only apply what is required by a given crop. Then the other measure is applying nitrogen fertilizer in appropriate amounts and in a timely manner. So we only apply when we are sure the plants will be able to utilize the given fertilizers. The other measure is diversifying crop rotation so that we are able to minimize the effects of nitrogen fertilizer. And then we can also apply irrigation water and manure with a high content of calcium or magnesium bicarbonate. Using other organic ways like organic fertilizers or using other methods like no-till cropping systems and crop rotation can also help in reducing acidification in a given soil. And then for us to increase soil pH, we can apply materials like limestone and wood ash. And we say that the finer the limestone, the more rapid it becomes effective. So when you're looking for limestone to use, you should look for limestone that has a finer texture. We also see that wood ashes contain high amounts of potassium and calcium, so we can also use them in order to increase the soil pH. So how can we decrease soil pH? Soil pH can be decreased by using aluminium sulfate or sulfur instead of ammonium based fertilizers. And we see that of the two, aluminium sulfate is preferred just because as soon as it dissolves, you're able to see the results. But sulfur takes a much more longer time for it to show its effectiveness. Thank you so much for listening, and in case you have any questions, kindly send them to me through my email or through the UCU Learning Management System. May God bless you.